Now we're going to go on to, now you can put the heading, finding the equation of a tangent at a point. So let's now find the equation of a tangent at a point. In fact, no. Put the heading, differentiation. Differentiation. So this is also finding the derivative, but for more complex graphs. Remember in our checklist, this was number 3. So differentiation for more complex problems. Now differentiation will be done, it's finding the derivative in certain processes. It must be done in these 3 steps, B, D, A. Before differentiation, differentiation or derivative, and after differentiation. Okay, you need to do it in these 3 parts. That's the rules. That is the process of differentiation. Just think about it, before death, death and after death. Right, so before differentiation, differentiation, after differentiation. Okay, so before differentiation, what do we need to do? We need to get rid of unknowns from the denominator. We need to get rid of brackets. We need to get rid of third signs. We need to get it linear. What does linear mean? Straight line. We need to get it in a straight line. D, the next, derivative. And that we know, how do we find the derivative? Using what? Using the power rule. And after differentiation, we write our answer with positive exponents. Okay, so before differentiation, get it linear, get rid of brackets, get rid of third signs, get rid of unknowns, not knowns, unknowns from denominator, bring it up to the top, get it all in a straight line. Once you got it all in a straight line, now you find the derivative for each one of them. Make sure in your final answer that the answer must be with positive exponents. So let's start with various types. I'm going to do about 4 types, 4 examples of differentiation. If you can do these 4, you can do them all. Okay, so let's start with type number 1. Let's start with type 1. Okay, now another thing before we start. If a question is given in terms of f, your derivative will be given in terms of f dash x. If it's given in terms of y, you're now going to say dy over dx. If it's given in terms of dx, like this in brackets, when you're finding the derivative, you'll just say is equal to and blow out the brackets. So these are the 3 different types in which derivative will be given. Okay, so if it's given in terms of f, you cannot say df over dx. If it's given in terms of x, you say f dash x. If it's given in terms of y, you say dy over dx when finding the derivative. If it's given in terms of dx, you just remove the brackets at the end when you're finding the derivative. So these are just your 3 different styles in which you need to give the derivative. So let's start with type number 1. Type number 1 looks like this. If I tell you y is equal to 5x squared minus 3x plus 1 all over root x. Let's make that interesting. If I made it only over x, that would be very simple. Then we'll just take each one and put it over x. Right. So what is type 1? Type 1, what makes it unique? It's not that there's a third sign at the bottom. No. What makes type 1 unique is that there's one term at the bottom. So in our answer, we need to do the before part. Get rid of unknowns from the denominator, get rid of third signs and make it linear. So we're going to use our normal rules of exponents. So here we can even put it, just use your normal rules of exponents. So here goes. The before part, y is equal to 5x squared over root x minus 3x over root x plus 1 over root x. We make each, this root x belongs to each one of these terms. So y is equal to 5x squared over root x, square root x. If I had to remove it, we know there's a 2 there, we know there's a 1. So it's x to the power 1 over 2. Inside power divided by outside root. So it's x to the power a half minus 3x to the power 1 over x to the power half plus 1 over x to the power half. Now, we dividing and bases are the same. We subtract the powers. Remember from your rules of exponents, when you divide and bases are the same, you subtract the powers. So what am I left with? 5x to the power 2 minus a half is 1.5, and 1.5 is 3 over 2. Minus 3x to the power 1 minus a half is a half plus x to the plus half will come up to the top as x to the power minus half. We haven't yet found the derivative, guys. All we've done is we've simplified it. We've only done the b part of it, the before part of it. All we've done now is gotten rid of x from the denominator. We've got it linear. Now we find the derivative. So now what we're going to do? Apply the power rule. We're now going to say, therefore, dy over dx is equal to, now, power times coefficient, minus 1 from power. Minus 1, minus 1. Right? Remember, that's the rule. Power times coefficient, minus 1 from power. So, 3 over 2 times 5, 15 over 2. X to the power 3 over 2 minus 1 is a half. Positive times negative is a negative. 3 times a half, 3 over 2. X to the power half minus 1 is minus a half. Negative times positive is negative. A half times 1 is a half. X to the power minus half minus 1 is minus 3 over 2. Can that be my final answer? No. Your answer must be with positive exponents. So your final answer is going to equal to, derivative is now equal to 15 over 2 x to the power half minus 3 over 2. X to the minus half comes down as x to the power plus half minus a half x, minus a half. X to the power minus 3 over 2 comes down as x to the power plus 3 over 2. And there we go. That is your final answer. Guys, you should get 5 marks for that. Okay? Got rid of all the denominators, got it linear, applied the power rule, made sure that our answers were with positive exponents.